LESIA is in charge of space instrumentation for various missions in solar exploration and astronomy, and also for ground-based instruments for large telescopes. LESIA has already a long history. We had the first instruments flying on the sounding rockets in the 1970s. We had instruments on Cassini mission, on Rosetta mission, Venus Express, Mars Express, Stereo, many others. But recently we just delivered and launched instruments on Bepi Colombo, and we are now building instruments for the next ESA mission, Solar Orbiter, Plateau mission, Ariel mission, Mars Science Laboratory 2020. We are building with IRAP Space Laboratory in Toulouse an instrument called SuperCam, which will observe the Martian surface of various aspects in the near future.
Exoplanets are studied in many different ways at LESIA and using many different techniques. For example, people have pioneered direct observation of planets. There's a technique called coronagraphy that was developed at Paris Observatory 80 years ago. This technique has been revived since about 20 years ago to observe planets next to stars. But also another technique is to observe, so to speak, the shadow of the planet as it passes in front of the star. This technique was pioneered at LESIA with a satellite which was called CORO, which flew in 2006 and which discovered several dozens planets. And then the next generation of these transit detection satellites is called Plato, and LESIA plays a very important role with Plato, which will fly in 2026. It will observe the full sky and it will provide probably 10,000 planets or more.
We are deeply involved in the Solar Orbiter project. Solar Orbiter will be the next European space mission dedicated to the study of the Sun and its connection with the interplanetary medium.
We are responsible for one of the 10 instruments on Solar Orbiter. This instrument is the radio and plasma wave instrument, which is actually measuring and listening the radio emissions produced by the Sun. And in LESIA we have built the electronic box of the instrument, which has been delivered to Airbus.
Here at LESIA, we are the main group in France, which is studying solar activity from the eruption on the Sun to its impact on the Earth.
In LESIA, we have two groups working on space weather. The solar physics group, which is studying the origin of the perturbation by analyzing images of the Sun, and the plasma physics group, which is studying traditionally the solar wind, the density, temperature, composition, level of energetic particles, and the impact of the solar wind on the Earth.
On the observation side, we are observing the Sun in almost every wavelength, and we have a set of instruments which are unique in the world in radio, white light, and high energy particles. At the same time, we are developing numerical simulation which are able to really understand the way solar eruptions are developing and are happening.
LESIA is, of course, part of a network of laboratories. We work with brother laboratories in France, so we calibrate our own instruments, but also instruments from other places on request from the Space Agency and the request from any laboratories, even if we are not involved from the beginning of an experiment. We have in LESIA possibilities for thermal vacuum test for space experiments, and also the experience and the quality instruments that we have from a long history of development.
We have 8 clean rooms on the site, and this one was built with especially for planetary protection for the Mars mission. And we maximize the safety of the instrument and also the personnel working outside of the clean room in a dedicated control room. And so we avoid any contamination of the instrument, like particles or excessive humidity, and to avoid any degradation of the performances of the instrument.
The quality of the people that work here is very important for the success of our instruments, of our missions. Because we have very tight schedules, the schedule change quite often, and so people have to change their task. We have people that are very much involved in their work. They are really concerned with the success of the missions we work on, and so they always do the maximum to go to the success.
In the next 10 years, we already know what instruments will fly and what the observations will be. There are fundamental questions there we are addressing through instrumentation in LESIA, and we hope to have some answers in the next 10 years.